In this video, we're going to be finding the domain of natural logarithmic functions, and then we're going to work on a real-life application problem. So let's first revisit what we know about the domains of logarithmic functions. So in a previous video, we were talking about the parent functions of logarithmic equations or functions, and we talked about how the y-axis is a vertical asymptote of the graph of f of x equals the log base b of x, which also works for the natural log of x. Okay, so this would also work for the natural log of x, that we would have this y-axis as a vertical asymptote, which tells us that x isn't going to be able to equal 0. Okay, now we know that the domain of this not this asymptote, but of this function is that x has to be greater than 0. The same holds true for the natural log of x. X would need to be greater than 0 because we have our x, it has to be larger, because as we were finding the evaluation, like if we were to evaluate what the log of a negative number would be, we would get no real solution. So let's go back to our problem. And so here in our first example, we have the f of x equals the natural log of x minus 2. So what's happening here is this x minus 2 is taking the place of that x from before. So we want to take that x minus 2 and we want to set it equal to 0 and solve. So we're going to go ahead and add 2 to both sides and get that x equals 2. Now again, remember from what we just saw that from the parent function, its x has to be larger than 0. So we're going to replace our equal sign with a greater than symbol, which tells us that x needs to be larger than 2. Let's rewrite that a little bit different. So x has to be greater than 2. So that tells us that we're going to go from a 2 to infinity for our domain. So our domain is between 2 and infinity. I want you to go ahead and try letter B on your own. So go ahead and push pause, do letter B, and when you're done, push play, and let's see if you're right. So we're going to take our inside piece, our 2 minus x, and we're going to set that equal to 0. Then we're going to solve for x. I'm going to add my x over. And so here, I'm going to get 2 equals x. So in this particular situation, if we were to replace our original symbol with a greater than symbol, which we totally could, we would have here that 2 is greater than x. So just because we have the x on the other side doesn't mean we get to turn the symbol around. So this would be written as 2 is greater than, greater than x. Another way to look at this is if we had been solving it, if we had subtracted 2 from both sides, we would have had negative x equals negative 2 and divided by a negative 1, which would have given us x is equal to positive 2. And then when we went in to put in our greater than symbol, right, with our 2, we would have to change it because we divided by that negative 1. And so that's why we would have x is less than 2. So when I solved it this first time, all I did was I brought this symbol down exactly as it looks, right? Exactly as it looks. 2 is greater than x. So for final answer here, I would have that x is technically less than 2, which means that my answer would go from negative infinity all the way to 2 for my domain, which would be that final answer. Let's take a look at letter C. Here, we have an x squared in that place. So we're going to go ahead and go x squared is equal to 0. Now, if I wanted to, same with all of these, I could have put my greater than symbol in to start with, and that's not a big deal. You're more than welcome to do that, and it might even save you a little headache later. So from here, I can go ahead and I square root both sides, and that's going to tell me that x can be greater than plus or minus the square root of 0 is 0. Except that we know that x can't equal 0 because we have a vertical asymptote at x equals 0. So here we can say that x can be anything except for 0. So here we'll write down for our domain all real numbers except x cannot equal 0. And that would be the solution of our domain here. Let's take a look at this real life application problem. So students participating in a psychology experiment attended several lectures on a subject and were given an exam. Now, every month for a year after the exam, the students were retested to see how much of the material they remembered. And the average scores for the group are given by the human memory model that we see here, which is f of x equals 75 minus 6 times the natural log of t plus 1, where t has to be equal to or between 0 and 12. And t is the time in months. So it asks us what was the average score on the original exam, meaning when t equaled 0. So what that means we're going to do is we want to find where f equals 0. So we're going to take our 75 minus 6 times the natural log. We're going to plug in that 0 into the t's spot, plus 1. And we are allowed to plug in the 0 because 0 lives between 0 and 12 or is equal to 0 and 12. So if we take this, we plug this into our calculator. So we pull up our calculator and we can plug that in. So 75 minus 6 times the natural log of 0 plus 1. And we'll hit enter, and that's going to give us 75. So we're going to say that our f of 0 equals 75. Question B says, what is the average score at the end of 2 months? So this is very similar to letter A, except this time it's saying that t equals 2. So I'm going to have you go ahead and try this one and part C on your own. When you're done, push play, and we'll see if you were right. So here we're going to go ahead and plug a 2 in for our t value. So we're looking for f of 2. So we have 75 minus 6 times the natural log of 2 plus 1. So we pull up our calculator and we can put that in and hit enter, and we'll get an answer of 68.408. So we're going to go ahead and call that 68.41. So 68.41. And then for part C, we're going to be plugging in the number 6. So we're looking for f of 6. So 75 minus 6 times the natural log of 6 plus 1. So we'll pull up our calculator and we'll plug in our equation with a 6 and hit enter. And that's going to give us an answer of 63.324. So we'll round that to a 63.32. Because this is a real life problem, our domain is what was given right here. These restrictions are telling us that t has to be between 0 and 12 or equal to 0 and 12 in order to fit this model and be something that we can use. So in this particular instance, our domain was given because that's what fit our real life application portion of this problem.